be moving into DJ Schleen with Aetna. DJ is one of the people that we love hanging out with wherever we go, to the point that we're actually going to be taking him with us on a tour that's coming up, and I'm sure that DJ will be telling us about that. DJ, I'm looking at you. Are you unmuted? Can I hear you now?
Hey, Mark, what's going on?
Hey, there you are. Good to see you. I think we're here for competing beards. I think mine is outgrowing yours, though.
Oh, gosh, yeah. I got to do the scruffy, just get rid of the goatee.
Very happy to have you with us. I love hearing you expanding on what's been happening over the last year with Aetna, because your story is indicative of what's possible. And that's the thing that I like hearing you talk about. I remember when you and me and John Willis first met a year ago, and you had rolled out the story of, security across the entire enterprise. And John was just floored. And so now we're stepping up. It's a year later. Your story has continued to improve. So very much looking forward to having you talk to you about it. And go ahead and share your slides and we'll get started.
Absolutely. And it's great to be here. Okay.
There you go. You're ready to go. Thanks.
Absolutely. Well, hey, everyone. Thanks for attending. And today I'm taking this story a little bit further. Rather than just focusing on the pipeline, we're going to dig a little bit deeper into how to start automating software development, especially around the Nexus platform. And a lot of this is based on experience, not only where I'm working right now, but in the past and historically in jobs before I've actually came to Aetna. So starting off, the story really begins with this open source software, and I'm going to go on a little bit of a rant right now. There's many different repositories out there, Docker, Ruby gems. These are the things that Nexus platform supports and really allows us to work with as development operations and as security organizations a little bit better than we've ever had. Hackers know more about their code bases than all of us do. All this open source code that's out there in these repositories, and even Docker layers, everything can be deconstructed and utilized against organizations that use these components. Underlying base images are really riddled with errors and vulnerabilities when it comes to Docker. For example, there's one large company that produces software, not Sonatype, but we've seen this happen in the last couple of weeks where we acquired an image from this organization. And we ran it through our scanning tools, and we ran it through Sonatype lifecycle to find out the open source vulnerabilities. And we also ran it through some container vulnerability analysis tools. And we found out that they had 6 critical vulnerabilities, and they were distributing this software knowingly to their customers with these vulnerabilities included. For a large organization, that really introduces unnecessary risk, right? We definitely don't want to have that in our environments. We wouldn't produce this kind of software for our customers. So we want to make sure that anything that we're bringing into our environments don't introduce some vulnerabilities. So I always think that open source software is really just lunch for unicorns. You feed garbage in and you get garbage out, and then the security organization starts dealing with these incidents. And thanks to Pete Cheslock for this image, and of course hijinks ensue for the original graphic. So where do we begin? And that's the biggest question that organizations have. It's harder to start a race than it is to finish it, right? And when you find a good place to start, it's probably the most difficult thing, right? You can't really pinpoint it. Most folks just start with a build server and CI, and having code checked in by their developers, and they run a continuous or build server, and they call that continuous integration, and that's not really the way that it goes. Continuous integration is, constantly merging code into master branches and, doing feature branches and really having a thought out methodology for developing software, integrating it into your master branch, and then throwing that down some kind of pipeline tool. So, we'll look a little bit about branching and merging. And one of the favorite branching and merging strategies I like to use is Git flow. So we have this master branch, and that's your golden branch. Anything that you want to do, you want to protect that branch, make sure no vulnerabilities get into it. And if they do, you want to remediate them pretty much instantly. The way I have this documented, everything above this is development, and everything below this is things that go to production as releases. And we have continuous delivery and continuous deployment, two different things. But when we're deploying to our production environment, what we're doing is we're really tagging a release number. And then if we see something that happens in production, like a vulnerability or some kind of bug, we can either hot fix it. But in the age of containers, we just fix it and redeploy it. So we get used to that velocity. When you look at a development branch and a master branch, those kind of branches isolate each other, and you isolate the development team from that golden branch. And then features basically are just developers branching off of that dev branch in their own isolated environment where they can perform, they can code, they can have their own isolated environment where they can develop. And what these do is they give us a lot of automation opportunities. So if you know your branching and merging strategy, you already are ahead of the pack, where you can go in and say, well, every time we do a pull request, for example, that's an automation opportunity. Basically, what ends up happening, if you do a Git flow methodology, or really any kind of branching and merging strategy, if you do a pull request and try to get your development branch into master, there's a couple of things you can do there. You can run a lot of automated tools. You can do static code analysis. You can run a Nexus lifecycle open source scan. You can run pretty much any kind of tool as long as you have a good pipeline defined. And we're going to get into the pipeline a little bit later. But you can also take that opportunity to have humans look at this code base and do code reviews. So it's a great opportunity for an education, educating people in coding standards and linting and that kind of thing. So, merging is a great place to start introducing automation. The other place that you want to do it is you want to do it at a daily basis on the master and your release branches. So any kind of security vulnerability or security scan that's been done is only as good as the moment it was created or kicked off and the results came back. So things that are in the master branch, especially for software that hasn't been maintained for a long period of time, they could have vulnerabilities that are introduced at a later date. Because vulnerabilities happen every day. It seems like every day we have another crazy vulnerability that comes out, or crazy attack vector that's been discovered, or weakness in software. So we want to scan our master branches regularly and make sure that we get our results back. And then the other place we can look at automation is at the feature level where people are developing their software. So these are the IDE plugins that we're looking at. And this is getting that instant feedback to developers. So with these three types of automation opportunities, you're really covering a lot of the bases of performing security scanning or any kind of evaluation in your branching and merging strategies. So pipelines. And this is a slide that I have evolved over the past year and a half. And it's an interesting one. It really takes the idea of a feature from a product owner all the way to production environment and even beyond, because one of the things that traditionally happens is in non-DevOps environments is when an application goes out to production, it's usually forgotten. Either budgets have dried up, the project is over, and there's no cost center to support it. And that causes a lot of problems, because if there's a vulnerability, the first thing that happens is folks say, well, I don't have any budget for it. So, when you're thinking about product from a business perspective, you always want to bake in some kind of support into your production operations. And if you're running a continuous product and you're constantly developing it long term and there is no end date to this product development, you definitely want to take into consideration your production costs. and what's, how much that's operating, and what kind of vulnerabilities that are happening in that environment. So really quickly, what we're going to focus on here is, this is all application lifecycle management, and this duration could take minutes to hours. Sometimes it takes weeks. But what we want to do with DevSecOps or DevOps is really improve the flow and the velocity that we push things into production. And our automated steps, which is that green line across the top of this diagram, what that does is it separates concerns. So from a compliance perspective, you have different systems dealing with different pieces or stages of the pipeline. And then you can have handoffs between these stages where you can attest that the previous stage has actually been executed. So this gives that non-repudiation as the product goes through the pipeline. As well, all of these security tools that are in blue here, you want to consolidate those vulnerabilities. One of the problem areas that has been identified here for the last couple of months is we're running these scanning tools and we're getting all this vulnerability information from all the tools we're using, and there's a lot of overlap. And so there's two things that happen. Either you get a vulnerability that's in multiple locations, and then you have 15 different tickets or even 100 different tickets created if you automate work item creation. And that gets really complicated, especially to manage that from a business perspective. So what we're looking at is, an opportunity to consolidate these vulnerabilities into one specific work item that lists the occurrences. And that helps just contain the noise and really improves the flow of the process and the triage and the prioritization of a backlog. So from the vulnerability consolidation, one of the things we do is toss everything to our data analysis and security modeling group, and they perform security models to try to figure out, where something is going to happen next, maybe correlating a cyber event or a development event to a physical event that happens. So a lot of information comes out of that. And a lot of KPIs get distributed where we can monitor things like security drag, defect escape rate to production, these kind of really important DevSecOps and DevOps KPIs. And all this information as well goes back to the product owner, so they can make decisions, they can react to these vulnerabilities, they can prioritize based on severity and impact and likelihood, and put those things back into the pipeline and get the developers to work on specific tasks. And of course, all this information, if there are vulnerabilities that are critical, they go to our SOC and our Security Operations Center. And from there, we can actually manage the remediation of these issues. So imagine having an open source component that is pervasive across our enterprise. The SOC is going to manage this issue and manage that remediation and keep the enterprise informed of the patching or the exposure that we have to that vulnerability. So the Nexus platform sweet spot, I believe, is really between coding the infrastructure and a staging environment, and even into production as well. But from this diagram here, third-party components come in at the development level, and we can use the opportunity there to block specific third-party libraries or open source software that has a CVSS score that's 10 and even like 7, 3. The idea here is we want to point where our applications have 0 open source software vulnerabilities. And there's some different concerns around that, which we'll get into a little bit later. But that's sort of a scary concept for developers, where they're look at these components to help boot, give a bit of a head start to their development. And without those components, there's different options to use other components or develop, but that's a bit of a fear spot, and we'll dig into that a little bit later. Once we commit that code to our source control system, we can run different tools, and one of those is, again, scanning for open source components. And that's a backup more than anything else, because as developers are bringing these components into their environment and building their software, they might not check in on a regular basis. And that's a problem that I see a lot of places. You want to get into the habit of checking in multiple times a day. And that's mainly for merging and integrating with the master branch and just making sure your features don't get so stale that, the pipeline is completed or gone on and more features have been developed and checked in. And now you have a lot of merging issues and that kind of thing. And then when you check in, build that, let's say it's a container, and then we package that as an image, or build the image and then package it. What we want to do there is cryptographically sign the manifest, make sure that we have a bill of materials associated with that image, and then we throw it into our repository. And we use Nexus repository, OSS repository for that. And the nice thing about that repository is it's not just a place to store these images or these components that we develop internally, but it operates as a proxy to Docker Hub and, or to any kind of repository, PyPy, Yum, Maven. And what that allows us to do from a security organization is, as these components come into our environment, we know that they're there. So we have this ability to have this visibility that we've never had before. And then once that image is in that repository, and even before it goes into the repository, we can use the Nexus IQ API plugins for Jenkins. Really, it's very flexible, and we toss our image towards that just to make sure, again, that as we've compiled that together, that any vulnerabilities that have come in from an apt-get or from a wget or something into that image build doesn't have any additional vulnerabilities. So let's dig into when to scan for open source vulnerabilities. So again, I mentioned pull requests, and that's very important. What that does, you can gate things. So gating basically would say, we're doing this merge request, pull request. If there's any vulnerabilities over what we have agreed on, or if it's a brownfield development versus a greenfield, we just deny that pull request. Again, nightly or regularly, you want to do that scan as well. And that's scanning the actual repository, your source code repositories, running a pipeline that runs that, build through lifecycle or some other tool just to figure out, do you have any new vulnerabilities that you didn't detect because the product has, or the microservice has been in that registry or that repository for a long period of time. And really, it depends on what kind of tool you're using. I found that IQ and Lifecycle specifically are very fast at looking through these code bases and identifying these components, so these jar files or these Ruby gems or whatever you have, and finding out if there's any vulnerabilities about it. Some other tools take forever and could have a long period of time that they're executing. For example, I've seen some tools take up to 24 to 48 hours. That's because it's a really large code base and not necessarily open source software management, but those are static code analysis tools. And for those kind of things, you're going to want to run them regularly. So maybe once or twice a week, and have some allocated capacity to run these things. That's one of the problems that we're facing right now is as we start bringing teams onto our security tools and our DevSecOps pipelines and all of our architecture that we have available and our services we have available from a security perspective, we end up seeing that our capacity is really suffering. And that's a good thing to have, right? That means we're getting people interested in security tools and integrating these into our pipelines. And when that happens, we're building that culture of security and that culture of trust between our organizations, and we're improving the code quality of our applications. And then we also want to have these plugins and these tools integrated into our IDEs. And what that's doing is a couple of different things. First, it's helping gate the components that are coming into the environment. It's letting developers know that there are vulnerabilities potentially in that component that's coming in. And it lets the developer understand what these vulnerabilities do. If there's a new version of that component, it's one of my favorite features of Lifecycle is that, as you're looking at these things in the IDE or in the web interface, you're seeing when that vulnerability happened and if there's any new versions that potentially are clean. And that's gives the developers a lot of power, especially if they're developing a new piece of functionality. They can say, well, I'm going to utilize this new component and reduce those vulnerabilities that are coming into that code base. So some important concepts, and this will finish off the conversation. First off, automation doesn't equal DevSecOps. It sure doesn't equal DevOps, and it very much doesn't equal CI/CD. Automation without understanding and without handoffs, the cultural adoption, the buy-in from the business, and the decision making that happens between stages is not really CI/CD. It's a piece of it. So definitely getting started with automation is the first step. That's what Shannon Leeds will call crawling, and you want to get to, you have to start somewhere. So start automating, but understand that there's more to DevSecOps and DevOps than just tools and process. It's the culture around it as well. And the adoption of that in large enterprises especially is quite challenging, and it requires a lot of different buy-in from executives and business to really change the way that they've siloed their development and operations and security teams in the past. Getting a pipeline, there's a bunch of different pipeline tools available out there, such as Jenkins and GitLab. I prefer GoCD. I think it's very flexible. It's probably one of the coolest and strongest tools out there. A little bit of weirdness with it, but definitely love using it. And it's sort of my, excuse the pun, it's my go-to platform for pipeline. And then, of course, you got Bitbucket. Each of them has a different maturity level. These pipeline tools they're getting out of their infancy stages. I think, from an age perspective, if you compare it to your children, they're a teenager. They're getting there. And I think over time they're going to mature a bit more. But the number one thing you want to do is really ensure that these pipeline tools at least support the idea of scripting and custom scripting, and most of them do. And they have scripting add-ins where you can customize scripts, and then parallel processing and parallel tasks, in a build stage is also very important. And a lot of tools haven't got to that maturity level just yet. But when you can parallelize, multiple tasks in a build stage, you can actually save time. So for example, GoCD will allow you to do this. And you could have open source software scanning running while you have static code analysis, while you have some other thing running. Imagine a code base that has a client and a server you can build them at the same time on different parallel tracks. And if one fails, maybe they have a shared library, then the other fails too, and the whole stage gets failed. And then you can do some different operations, notify Slack channels. This is where that integration comes in, where you're not just shipping an email off to somebody that they don't read. Anybody who's sent an email to me knows that usually it falls to the bottom of the barrel. But when it comes to a Slack message or a chat room or instant message, I'm always there to respond to those. So pipeline tools, definitely these two features are something you want to look for. And then flow. This is very important, especially from a security tool perspective. And I had mentioned that, a lot of these tools introduce a lot of unnecessary drag, and we want to avoid security drag. And in fact, one of the KPIs that I look at is from the start of a scan, whether it's open source or static code analysis, I want an automated KPI that comes out of that, where I know the start time, the end time, and I know the duration. And based on those KPIs and how those relate to specific pipelines and product builds and product deployments, I can identify very quickly where the bottlenecks are and where I'm getting some friction in the process. And developers traditionally are very impatient. I'm a former developer. Well, I guess in DevSecOps, we're all developers. And as a hacker, we're probably one of the OGs of DevSecOps. But when we look at these tools, if you're waiting more than 5 minutes or even more than 2 minutes, you're missing the boat, right? People aren't going to wait for that. The other thing that you want to do is just don't arbitrarily fail a build in your automated pipeline just because a component comes back vulnerable, especially on the development check-in. What we do is we provide a warning in our build tools that say, you have a vulnerable component and it exceeds the threshold of vulnerability, acceptable vulnerability level in the organization. We'll let you put this into a staging environment so you don't disrupt the business from doing acceptance testing or the executives for seeing that there's progress being made on this product development, but we're not going to let you deploy it to production. And I think that's an important part of automation. You really have to understand that it's not just about development and operations and security. The products we build have a consumer and a customer at the end of the line. And customers and consumers, whether that's our business analysts or our product owners or our executives, they want to see progress. And especially our graphic designers, they want to check to make sure that it's pixel perfect. And the sooner we can get the code to them, the sooner they can react and give us feedback on our products. The other thing is we want to do limits and thresholds. And that's very important. The first thing you want to do with any brownfield application or existing application is do a baseline scan. You want to find out how many criticals and high and low vulnerabilities, and you want to cap it. So instantly, you just want to make sure that as the development continues to go on, you're not introducing any more vulnerabilities. And that's really important for existing applications and helping the business understand that, just because we now know that these things are there, doesn't mean we have to fix them immediately. And then you have different, time constraints around that. So critical vulnerabilities, that's a stop the press and get that thing fixed now. If it's a high vulnerability, maybe you have 90 days, medium, potentially 180, and then low, maybe 365. Your security team can look at these vulnerabilities in these components and say, well, based on the information we have, these two components together is really a high vulnerability. And so you can sort of adapt to those differences and those little specific problem areas, and then address those, potentially create another ticket, link the two, have them together. But these thresholds are important because, again, baselining it is very important, and introducing new vulnerabilities is something that's pretty much, you can put the line there and say that's unacceptable. And then by doing that, if a new vulnerability tries to get introduced, you can kick it back and move it left to the developer, and they're the perfect person to make sure that it can be remediated. If you wait too long and you're not moving product issues and vulnerabilities left towards the folks that created this code base or this feature or this check-in, you're going to get into a situation where, let's say that person leaves the organization, or they join a different group or something to that effect. You're going to bring someone else in to try to fix and remediate that issue, or even on the same team, but it's at a later date. And they're not going to know where that issue was. They're going to have to look through the code, learn it. And that's going to be disruptive, and it's going to really decrease the velocity that team or that individual can develop and ship product out to production. So you want to make sure that you have these limits. And then as you start remediating the issues, continuously lower the limit so brownfield applications have the same quality that greenfield applications can have. My other piece of advice is not to fear the CLI, or, another word for it is my IDE doesn't support plugins. And just because, some users in our organization specifically, they use Visual Studio or they'll use Eclipse, and there's plugins readily available for those tools. Myself, I love using Micro or even VI. And for those tools, having a plugin, you can develop them. There might not be something available, but with the CLI tool that's available. For example, the Nexus IQ CLI, you can send information, send product and tar files or whatever you'd like to the lifecycle and get a result back. And it's very configurable, very usable. And, you can take these scripts or build these scripts into your pipelines or into your IDEs as some kind of automation script, and you're going to get the same functionality that you have with these supported and consumer-based commercial plugins. So definitely don't fear the CLI and interacting with things on a shell-based level and scripting around them.
DJ, we're coming up on a 4-minute warning.
Oh, okay. I'm almost finished here. So the last couple of things is having that bill of materials and that manifest. Make sure that everything from an open source component perspective to the contents of your images in a container, the libraries that you're using are in one consistent and concise format in one location that follows your product through to production. If you have that manifest, what components are being used, you can do a couple of different things. First, if you have an event that's a vulnerability or something that's come out that the fire drill is on, you can identify where those components are. And there's tools that do that too. But having the manifest, it makes things very easy to isolate and identify at the production level. And the other thing that you want to do with these is just make sure that the components that you have in your container images, for example, are valid. I've said many times over the past year and a half that having a Bluetooth driver inside of a container image doesn't make any sense, or even a desktop environment. Make those images as small as you can, and you're really reducing your attack footprint. And the last thing is, adopt DevSecOps. Take the time in your organizations to understand that open source components are probably one of the biggest things that can introduce vulnerabilities. And again, that code is open source, so people everywhere know that. You want to make sure that you know what the risk is of using these components, and you want to make sure that development and securities and operations understand what these vulnerabilities actually mean. For example, let's say there's a SQL injection or some kind of command injection. These things have been around for 15 years in the OWASP top 10, and not understanding what these things do or what these things can, the impact it can have on the organization, is probably a great, not failure, but a great topic that needs to be discussed. So with that, adopt DevSecOps, take the time, break down those silos and communicate with each other, and you're going to have more successful software delivery. So with that, thank you very much. And I think we have a couple minutes for questions and a strangling PyPy logo in the bottom corner of the screen.
There you go. I had to show you my beard here because I told you we were having a competition, right? One of the things that you said, DJ, which I thought was fascinating because there is another camp to it, is if I heard you correctly, you said, I don't fail the build because of a bad component. I move the build through the pipeline, giving the other teams downstream the chance to do their work while we're making the fix. Did I hear that properly?
Absolutely. I think that it's very important that we do that. Hopefully I stop screen sharing here. Oh, there we go. It's not just about the development and operations and security team. It's about the whole business, right? And I think that's the culture of communication that I've seen happen here, and I really think can happen anywhere. Again, it's going to vary from business to business and organization to organization, but again, it's not about just arbitrarily failing something. And if you keep failing the builds, for example, and your executives don't get a piece of product, then all of a sudden your business analyst, you're going to get this friction. You're going to get these questions like, well, what are you doing? Is DevSecOps working? And, that's something we want to avoid. We want to avoid that kind of, negative perspective of, what we're trying to accomplish here.
Thank you so much. Always good to talk to you. We'll see you in Singapore.